Hello and welcome to another wonderful day that will be handling physics. It's actually raining heavily here, so I'm gonna ask to know whether you guys can hear me before I can start. Tika, can you hear me?
Yes, I can hear you. Yes, I can hear
Tika, I
you.
did not hear you.
I can hear you, sir.
Okay. Buchi, Choma, can you hear me very well? Like,
Yes, sir, I can hear you.
okay, so let's continue since you guys can hear me. Today we're gonna be looking at a very short topic in physics known as friction. And whenever you have two bodies, one moving on the other one, there is always friction. Take for instance, if a car, the tire of a car is moving on top of the tarred road, because of the two surfaces in contact, the surface of the tire of the car and the surface of the road, there's going to be frictional force. So if the car is moving in this direction, the frictional force is moving in the other direction. So frictional force is always moving opposite to the direction of the other body that is supposed to be moving. So any of such force between two bodies or two surfaces that acts opposite to the direction of the motion of the other object, it is known as frictional force. And that's why we say friction is a force which acts opposite or which opposes the motion. So one of the surfaces, the motion of the other surface on top of the other one is being opposed by the force known as friction. So that's why here we say that friction is a force which acts to oppose motion at the surface separating two objects in contact. So it must be between two objects that are in contact. Okay, some frictional forces have to be overcome before an object can move over another. Now we have what we call static friction, which is the maximum force that must be overcome before an object can just start to move over another. Now we have the laws of friction. Friction opposes the relative motion between two surfaces in contact. Frictional forces depend on the nature of the surface. So you're going to have in your JAMB exam, which of the following does frictional force depend on? So it depends on the nature of the surface. Nature of the surface. That's the key word, nature of the surface. And it is independent of the area of the surfaces in contact. It depends on the nature. And when we say nature of the surface, we mean whether the surface is rough. If it is a rough surface, the friction will be very high. But if it is a smooth polished surface, it will be depends on the nature of the surface action. And that is a more likely question. Static friction, mu and frictional force, and R is the normal. Okay. So Okay, sorry. Like I said, it's raining heavily here, so the network might be tripping from time to time. But did we get the last thing I explained before the network trip? I was trying to ask whether you guys got this first flashlight. This first slide, did you understand it?
Sorry, I didn't get what you just said.
Okay, I was asking whether you guys got this first slide. I wanted to move to the next slide before my network went out.
Yes, sir, I understand this.
The first
Yes,
slide
sir.
is it clear? Okay, so let's move forward. Please, I'm bringing my face very close to the camera and I'm trying to shout just because, like I told you, it's raining heavily here. I cannot even hear myself from inside here. So that's why I have to bring my face very close to the computer so that you can get me very well. Okay, so let's move to the next slide. Okay, so the next slide is all about a given example. And it says a block of wood weighing 4 newtons is placed on a horizontal table. It's placed on a horizontal table. It is then pulled by means of a spring balance attached to one of the ends. Now the block just begins to move when the spring balance records a horizontal force of 2.5 newtons. What is the coefficient of static friction? Okay. So it records a horizontal force of, so a block of wood weighing, so you can see that the weight of the wood is 4 newtons. And it's placed on a horizontal table. It is then pulled by means of a spring balance attached to one of its ends. The block does begin to move when the spring balance records a horizontal force of 2.5. Then what is the coefficient of static friction? So we can easily get this from the formula that we have written earlier. Okay, so coefficient of static friction is also force over the reaction, normal reaction. So force is 2.5, normal reaction is 4, making it 0.625 as the coefficient of static friction. Okay, now in friction, this normally comes out the advantages of friction and the disadvantages. And JAMB is going to ask you, which of the following is not a method of reducing the effects of friction? So you should know the methods of reducing the effects of friction. You should know the disadvantages of friction as well as the advantages. So let's start with the advantages of friction. Number one, it is impossible to walk or stop without friction. So friction is very, very important. Imagine if there is no friction between your sandals and the floor. Once you place your leg, you will just slip. You will just slip. Everywhere will be slippery. If you're walking everywhere, imagine when you want to come out from your bathing and you're inside your bathtub. You want to come out from the bathtub and now place your leg on the normal floor of the bathroom. Is it because of the soapy nature of your leg and the whole environment? You always almost want to fall. So imagine that your sandals is not having the kind of rough edges that it has below. Let's say this my slippers now that I'm using. You see the floor, you see the way they made the surface. It's in such a way that it can help in exerting some level of friction between this and the floor that I'm working on. So in such a way, you have something to hold you so that when you're marching as you're walking, you can move at the pace at which you intended to move. So friction is very, very important. It is impossible to walk. That means without friction, we wouldn't have been walking majestically. We were able to walk because of the friction between the soles of our shoe and the floor on which we are placing our legs on or our foot on. So friction is very, very important. Then number two, friction enables automobile tires to make a firm grip with the roadway. The same way that friction is needed for us to walk, the same way if you're driving, the tire of the car and the surface of the third road, there is friction that is enabling it to move. If not, it will just brrr. So friction is very, very important. Very, very important. Number 3, it is utilized in fan belts, used over wheels or pulleys in machinery. Very, very important. In our mechanical arrangements, you have the wheels and pulleys. They are held onto these wheels and pulleys by friction. Now, friction enables brake to stop. Imagine if there is nothing like brake. Apply brake in a car. The brake in a car works because there is friction. So once you match your brake, it will go and heat up through pneumatic pressure, make it possible for the car to stop due to friction. Then friction is also used to sharpen knives and chisels. Who has witnessed this? In the village, when I was growing up, when my dad will always drive us to the village during Christmas celebration. So there are people that my grandfather normally invite to come and kill goats for us. So when they bring knife, they have to sharpen the knife on stone. So the knife is sharpened by the frictional effect of the stone on the knife, making the knife to be sharp. So once the knife is sharp, once you put it on the neck of the goat, it will just slice off the neck. So the stone is able to sharpen the knives or chisels because of frictional force. That force that is opposing its motion, making it to start having wears. So parts of the knife will start going out, making it to remain the sharp knives and chisels. Now, what are the disadvantages of this friction? Number 1, it leads to wear and tear in moving parts of machine. Like I told you, when you're sharpening the knife on the stone, so it's wearing out parts of the knife. That's why the knife becomes sharper. But if it is in terms of parts of machine, when that wear is going on, it's making your to be weaker. So when you hear it leads to wear and tear, simply means it leads to spoiling. So your machine tends to spoil after some time because of the constant friction between the parts. And that's why you apply oil. They will tell you to put engine oil. Engine oil enables the parts of the machine to move freely and reduces friction so that the machine will last behaving well. That's why if you don't put oil in your generator, the parts of the generator, the mechanical parts will be scratching each other, and all of a sudden the engine will knock. Because you've not applied enough fluid, which is the oil that will reduce the friction. Okay, number 2, much useless work is done by machine in overcoming friction, which opposes their motion. Okay, so a machine will have to overcome the force of friction before it can even do useful work. So in that case, friction, like I said, if metal parts are grinding themselves together, it will cause heating. It will cause worn-out parts, and it will cause wear and tear, and as well as heating. So, but if you apply something like grease and oil, it will help you to move faster or to move the right way. So methods of reducing friction, like I said, how do you reduce friction? By using lubricants like oil, grease, air, and graphite. So these are examples of lubricants that can reduce friction. And JAMB is going to ask you, which of the following is not a lubricant that can help in reducing friction? So know that oil is a lubricant, grease is a lubricant, also serve as a lubricant. Then we also have the use of balls and roller bearing, very, very important. Balls and roller bearing, they enable mechanical parts to move. You know all those small balls that you see in your some mechanical parts. So they enable free movement, reducing friction. Then finally, streamlining of body shapes of moving parts. If you look at submarine, all of them is built in such a way that you can easily move, swim. So that special kind of shaping of an object enables it to move faster and avoids friction. That's why you have to streamline objects if you want them not to meet friction. If you build your ship and your ship is just having a 4-corner shape, it will not be able to swim. The friction caused by the water friction due to viscosity is going to make it not to move. And that's why you must build it in such a way that it has a piercing mouth, something like this, so that it can move. Streamline body. When you hear streamline, streamline means having the shape of a fish. It can move. If you look at your aeroplanes, all of them are built in that way so that they can easily move without the frictional force caused by air on them. Okay. So Chika, this slide, I hope this slide, I think I did justice to it.
Yes, sir, you did.
Okay, Buchi, Choma, did I do justice to it?
Yes, sir, you did justice.
Okay, Blessing, did you understand? You joined late. Did you understand this slide? Okay, Timothy Ruben, this slide, is it clear? Timothy, if you want to talk, you need to unmute yourself. Okay.
Yes, sir.
Yeah, how are you? Yeah, how are you?
I'm good, sir. I'm understanding.
Okay, so let's move forward. So everybody can mute back. Everybody can mute back. So for a static friction in an inclined plane, so this is the formula for the coefficient of friction. So F over R can also be equal to tan theta. Okay, so now let's move to the JAMB past questions to see likely questions that we can see on friction. So we'll start with the first one, JAMB 1995, physics question number 13. Which of the following statements are true about frictional force? So which of the following are true about frictional force? It is always disadvantage. Chika, can this first statement, it is always disadvantage, can it be true about frictional force?
No.
No, good. It cannot be, because we know that frictional force can be of advantage in terms of working and in terms of many other things. So that alone makes I cannot be a true one. I cannot be a true one. Timothy, you want to say something? Timothy, you want to say something?
No, continue.
Okay, please put your voice on mute so that your background is reverberating while I'm talking. Okay, thank you very much. So let's continue. Statement number 2 say it is sometimes disadvantageous. Choma, that statement, is it correct? It is sometimes disadvantageous.
Yes, sir.
Yeah, it's correct, because sometimes friction is not good. But it's not that it is not always good, but sometimes it could be disadvantageous. And in that case, when it's producing useless work for machines, or when it is opposing active work, it will be disadvantageous. So number 3, it always exists where there is relative motion of two bodies that are in contact. I think this is very correct, because friction can only exist where there are two bodies that are in contact. Friction is a contact force. Without contact, it cannot work. Chioma, but you give me 3 examples of forces that are not contact force. Good examples of contact force are, number 1. Let me give you guys this. This is very important. So there are 2 types of forces. 2 types of forces. You might not learn this. That's why I'm telling you this. So number 1 is what we call the contact forces. These contact forces are forces that need contact. Before they can work, they must need contact. Good example are pull. Before you can pull something, you must be holding it. Push. Before you can push something, you must be also be holding, you must be touching it. Then we have friction. So these are examples of contact forces. Then we have other forces that are not contact forces. So these forces, they call them field force, field forces. So they don't need to touch you, but you feel their effect. The examples are gravitational force. All the electromagnetic forces are field forces. Electromagnetic Electromagnetic.
Sir, what of induction?
Induction.
Yes, sir.
Yeah, all those are induction is under electromagnetic induction. So all of them are field forces. They don't need to touch you, but you'll be feeling the effect. Just like now, if you bring a magnet close to a solid something, it will start dragging the magnet without the magnet touching the solid. So the magnet, the steel is already feeling the force of the magnet, even without touching it. That's why I call it force field. They act within regions without contact. Whereas contact forces are forces that you must be in contact with before you can feel their effect. If somebody wants to pull me, he must come and hold my hand and be in contact with me and pull me. If the person wants to push me, it must touch me in order to push me. Then if friction has to happen, it has to happen between two surfaces that are in contact. So all these are all contact forces. Whereas gravitational force that you have, once they throw you up, you don't need to touch the earth. You will start falling immediately. The Earth's gravity will start pulling you even without touching it. If you bring something, a magnet, a steel close to a magnet, it will start pulling the steel immediately, even without touching the magnet. So once you don't need contact in order to exert the effect of the force, call it field force. But once you need contact, call it contact force. And JAMB is going to ask us, which of the following is not a contact force? It will say pull, push, friction, and gravitation. Then you should know the answer is gravitation. Or if you say, which of the following is an example of field force? These are examples of field force. Chama, am I clear on this?
Yes, sir.
Okay, so let's look at it. Is sometimes very useful. Okay, that's number 4, very useful. When you say very useful, I don't know. So I think that is why option, you can see from our knowledge now I and I, 2 and 3 are the most perfect choice of 2 options that should be right. And that's why option C is the right answer. Chika, do you agree with me?
Yes, I do.
Choma, do you agree?
Yes, sir. I agree perfectly.
You agree? Did you
Yes,
say
sir.
partially
I
or
agree.
perfectly? Okay,
Perfectly.
perfectly, okay. So I think that is very clear. So let's move forward. And this is question number 3 in JAMB 1997. A 5 kg block is released from rest on a smooth plane inclined at an angle of 30 degrees to the horizontal. What is the acceleration down the plane? Then acceleration is given as G equal to 10. So we have answers 50 meter per second, 5.8 meter per second, 8.7, and 2.5. So acceleration, considering A in the direction of the inclination of 30 degrees, that's why we're having sine theta. So mass is 5 mg, mass times g, which is 10. So at the angle of inclination, which is 30, and that's why we're having sine 30. Okay, so we have force is equal to this, then A is equal to this sine theta. A is equal to 30. Who can tell me the error with this solution? Somebody should solve this and let me know the answer. Is there any error in the solution? Jama, can you try?
Sir, I really don't
I don't
know.
think
But the
there's error.
calculation, yes, there's not.
There's
Except
no
they've not
error, yeah.
used 5 kg.
So this force is equal to this. So that means that A here is taken in the component of the inclination. So A is just the same as this. You can take out M, take out M. A is the same as G sine theta. And this is A, that's what you're looking for. G is 10 sine theta.
Sin theta is 0.5. 0.5 times 10, 5. So option A is the answer. Check, I hope it's clear.
Yes, sir, it is.
Okay, so let's move forward. Let's move forward. Okay, we have this JAMB 2000. Question number 3. The frictional force is independent of the area of the surface in contact. Chika, is this statement true? Chika, is it true? The first statement, is it true? Choma,
Yes, sir, it is.
yeah, it's true. That was the when we checked the law of friction. That was the second statement there. After the first statement that says that friction opposes the motion of the body on which is moving on. Then we say that friction is independent of area, but depends on the nature of surface. And when we mean nature, we say things like the smoothness, how polished the surface is. That's what friction is dependent on. Friction does not depend on whether the surface is so big or that. Okay. Now, number 3, the frictional force depends on the speed of sliding. And number 4, the frictional force is directly proportional to the normal reaction. So which combination of the above is true of a sliding friction? So option A says that A, I, and IV, which are, so all of them are true. We know that friction is independent of the area of the surface, and friction depends on the nature of the surface, and it's also directly proportional to the normal reaction. So option A is the correct answer to this. See, that's why it's good we are looking at past questions immediately. So with this, we are able to capture all the likely questions that is going to be coming out from this. Okay, so let's move to the next one. So this one says, if an object just begins to slide on a surface inclined at 30 degrees Celsius to the horizontal, the coefficient of friction is what? We know that the coefficient of friction is equal to tan theta. We know from our formula, the last formula we gave, we say that coefficient of friction mu is equal to F over R, which is also equal to tan theta. So simply say tan theta. Theta is 30, so tan theta is 1 over sub 3, making the answer to that. Okay, we have this, 100 kg is pushed along a road with a force of 500 Newton. So please, whenever you hear kg in terms of
Sir, can you hear me?
Hello.
Yes, gone off.
Okay.
I think we should wait for him.
All right, no problem.
While waiting, can we ask ourselves questions? I don't know because I really don't understand the coefficient of force, which is F all over R.
You can tell the man when he comes so he can explain it to you. Or is it just the calculation or the formula you don't understand?
No, like what stands for? Like the F is for the force and the R is for the normal reaction.
Yes.
Okay.
Yeah, sorry. I hope you guys understand. Like I said, it's raining heavily here, so like I may always have to go and the network might not be so good and take me off and on. Yeah, but are you there, Choma?
Yes, I'm here.
I hope this slide is very clear.
It's clear, sir.
Okay, so let's move forward. This is just so this simple formula for coefficient of friction. You need to memorize it, and it's simply equal to frictional force over force of reaction. So if they give you weight,
It's not yet back.
I think it's having network issues.